2.6 is a review of something that I think you remember pretty well from algebra, and this is looking at transformations or translations. So the idea in this section is you can kind of create the graph of a pretty complex function if you can kind of piece it apart by identifying basic transformations and do a step-by-step process. So what I'm going to start with here is just making a very rough sketch of each of these functions. So first thing I have to do is identify what the base graph is. In other words, what family this guy belongs to. So this guy is a y equals x squared. Okay, so that means I have a parabola. Okay, so really rough sketch. All right. And then the next thing is, can I identify what the transformation is? So what I've done here is I've added 2 to the entire function. So added 2 to the y values. So that means I've moved the graph up 2. So very rough sketch. We'll do some nicer sketches later. It would look like so. Okay, what about number 2? Base graph is an absolute value. That one you'll remember is a V shape. Very rough sketch. And then identifying the transformation. So here I've subtracted 3 from the whole function. So from the y's. So move the graph down 3. So very rough sketch again. V shape, shifted down 3. Okay, what about number 3? So notice the difference. So I meant this one. Let me start this one over actually. So I wanted this one to look like number 1, but I wanted to make a change. I wanted to put that 2 on the inside. Okay, so notice the difference there. That 2's on the inside versus up here it was on the outside. So that means that that is actually affecting the x as opposed to the y. So up here we had, these were vertical shifts. Shifts up and down. Okay, so here I actually have a horizontal shift. So the thing is, because typically we think of y as a function of x, y things happen directly. So vertical shifts happen just like they seem like they would. Adding 2 moves the graph up 2, subtracting 3 moves the graph down 3. Horizontal things are opposite of how they look because we don't typically define x as a function of y, we do the opposite. So I still see here my basic graph is a y equal x squared. Okay, so again, very rough sketch, my parabola. Do a little bit better if I can, a U shape. Okay, something like that. All right, so here it looks like I'm adding 2 to the x's, but I actually do the opposite. So I'd actually subtract 2. So what we can do is we can verify that. When I draw the graph here, we can double check the vertex lands in the correct spot. Okay, so move everything left 2. Okay, now try plugging -2 in the function. So if I plug -2 in here, -2 plus 2 is 0. So indeed, that vertex is located in the correct spot. So it is indeed a shift left 2. Okay, so that guy, there's the final graph of that. And then look here, number 4 is very similar to number 2. But in number 4 here, see how again that 3 is on the inside versus in 2 it was on the outside? So that means this is going to be a horizontal shift. So I still start out with that absolute value of x, so that V shape. Okay, like so. But then I move the graph right 3. Opposite of how it looks. So it looks like I'm subtracting 3 from the x's, actually adding 3. It looked like that. Okay, so again, then these guys were the horizontal shifts affecting x, so left and right. And those are opposite of how they look. Okay, so those are shifts. So what else is there? Excuse me. So what about multiplications? So again, first identify my basic function, root x. Do you remember what that one looks like? So do a sketch of that graph here. Got 0, 0. Square root of 1 is 1. Square root of 4 is 2. And then one more maybe. Square root of 9 is 3. So there's my square root of x function. Okay, because look at the 5 versus 6. So you see how in 5, let's do it this way, I'm multiplying the whole function. So I take y equals square root of x, and I multiply the whole function by a negative. So what has become negative there? The y has become negative. So what's happening here is I'm taking y and making y negative. So if I take all my y's and make them negative, so look at what's going to happen. So let me draw a coordinate plane here, I guess. Okay, so look, now I'm graphing y equals negative root x. So each y, I'm just following this rule, each y is going to become negative. So in other words, like this point here at 1, 1, I take the y and make it negative. Now 0, 0 is not going to move. This point at 4, 2 is going to be at 4, negative 2. Okay, and then this guy at 9, 3 would be at 9, negative 3. So there's that graph. So what's happened here? So when I take my y and make it negative, which axis am I reflecting over? Well, aren't I reflecting? I'm taking the graph and I'm reflecting it down over the x-axis, right? So what I've actually done here is I've reflected over the x-axis. Okay, versus, look at number 6. So in number 6, what have I done there? Well, here I take my root x function, but what do I make negative here? I make the x negative. So you see how that negative is actually underneath next to the x? Okay, so what I'm going to do is I'm taking the same base graph, so this guy, my square root of x, okay, but this time I'm going to follow this rule. Okay, I'm making all the x's negative. So let's see what that graph's going to look like. Actually, I'm going to need more space. So do it this way. Okay, so now I take each point. Clean this up a little bit. So starting with the same base graph, but now I take each of these points like 1, 1. So now if I take 1, 1, I make the x negative. Now that point is at negative 1, 1. Take 4, 2. Make the x negative. Okay. 1, 2, 3, 4. Negative 4, 2. Negative 9, 3. Okay, so there's the graph of square root of negative x. So what have I reflected over there? So you see how this time I actually took this base graph up here and I actually reflected over the y-axis. So this is reflect over the y-axis, make the x's negative. Okay, what else is there? So what about multiplications by numbers? So here, let's see, my base graph is x squared. A little sketch of that guy again. It's a parabola. So, okay, so now what do? I take that function and I multiply it by 2, right? So what is my rule? What is happening here is I'm multiplying all of the y's by 2. So I'm going to take y and I'm going to multiply it by 2. So y is being affected, so this is a vertical. And then is y getting bigger or smaller? Well, if I'm multiplying it by 2, it's getting bigger. So we would call this a vertical stretch. But all I have to do is take each of the points and then follow this rule. So just multiply the y values by 2. And then I'll have a stretched parabola. So I'll have 1, 2. Right, I'm taking this, multiplying the y value by 2, do not affect the x value. And then negative 1, 2. So I have a skinny parabola, vertically stretched. Okay. Versus something like number 8 here. So I have the same base graph, still a y equals x squared. Okay, but what have I done this time? So I've taken y equals x squared and I've multiplied it by a half. Okay, so what is my rule? My y is multiplied by a half. So what's happening there then? Well, I'm still affecting y, so I call this a vertical something. But y is being multiplied by a half. That's the same as dividing it by 2. It's getting smaller. So I'd call this a vertical compression, or you could say a vertical shrink. Same thing. Okay, so I take the base graph above there. This one, right? And I just take each point. Now I follow this rule, multiply the y by a half. So that point at 1, 1 would be at 1 1/2. And then negative 1 1/2. Okay, so I have kind of a shallow, smush down parabola. Okay, so one more set of basic transformations. Then we're going to look at how you kind of put all this together to do some fancy functions like what's down there at the bottom. So difference with number 9 is this. Okay, so you still start out with square root of x like what we did up here. So let me maybe copy this guy down. Here's our base graph. So our base graph is that square root of x function. Again, there's that. Okay. But then do you see the difference here? So now I'm taking root x. I'm not multiplying the whole thing by 2. That'd be affecting the y. What I'm doing instead is I'm taking root x and I'm multiplying inside there. So I'm actually affecting the x. Okay, so that means I have a horizontal something. X goes to something. Now, do you remember, so with the shifts left and right, it's the same idea. Horizontal things happen opposite of how they look. So you see how it looks like I'm multiplying the x by 2? What I'm going to do is I'm going to do the opposite. So what I'm going to do is I'm actually going to divide the x by 2. So again, we can check that when we actually draw the graph and make sure the points line up correctly. So if I'm dividing the x by 2, then actually the x is getting smaller. So this is a horizontal compression. So let me see if I can plot these points. Did I put that so far over there? Might be over here still. Okay, so I take each x and divide it by 2. So now I'd have a half 1. Then let's see, 4, 2, divide the x by 2. 2, 2. Then 9, 3, be at 9 halves. 1, 2, 3, 4, 4 and a half. 9 halves. 3. Okay, so it's horizontally compressed. Now you can check that. Like if you pick one of these points, I don't know, pick like 2, 2. If I take x equals 2 and I plug it in the function, what do I get? I get square root of 2 times 2 is square root of 4. Oh, look at that. The result is 2. So that point is at the correct location. Okay, so the horizontal things are a little bit funny. So if you look down here, okay, same idea. Let me start with this basic graph again. Square root of x. It's the base graph. Get these out of the way. And we could probably get rid of those. Huh? They're already on the graph. Okay, so look at this one. So again, you see how that half is underneath the square root? So I know it's going to affect x. So it's a horizontal. Now remember, horizontal things are opposite of how they look. So what it looks like here is it looks like I'm dividing the x by 2. So be careful, I'm going to do the opposite. So I'm going to actually multiply the x by 2. So actually the x is getting bigger. This is a horizontal stretch. Okay, so I'm going to take each point here and I'm going to just multiply the x by 2. So now, let's see, this guy, we got 2, 1. Let's see, this guy be at 8, 2. And that's probably enough. Next one's not going to fit on there. Do a very good job drawing it. Stretched out half parabola. Okay. So now that we know what each of these basic transformations does, let's look at something a little more interesting. So the idea really is, can you take some of these basic building blocks and use those to put together a more complicated graph? Like the graph of a function, say, like this. Okay, so I have to kind of do this in pieces. So the first step is identify the base graph. So should have maybe left a little bit more room. I'm going to move this down a little bit here. Okay, so first thing, I look at the function and I say, well, what type of function is it? Like, what family does it belong to? What is the basic shape? So with this one, I see y equals x cubed. So graphing that parent function is my step 1. Okay, then I'm going to look at taking it apart and seeing what the other steps correspond with. So x cubed, I mean, I know what that looks like. It's something like that, right? I mean, I could plug in a couple values. So 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, -1 cubed is -1. -2 cubed is -8, okay, etc. I'll try to do a better job graphing it if I can. Something like that. There we go. So there's my parent function, my y equals x cubed. Okay, so now I'm looking at that function. I'm saying, well, I have to decide on an order to do the transformations. Otherwise, I'm not going to know what my next step is going to be. So the way I think about this, when I'm thinking about the order, so how am I going to choose my step 2? So here's what I like to do. Get rid of some of this so we have a little more room. So I like to think of it this way. So if you think about the order of operations for algebra, you think about, okay, what comes first? If I think about order of operations, what comes first? Multiplications and divisions or additions and subtractions? Well, multiplications and divisions come first, right? So this is the way I remember this. So I say, I need to do any multiplications and divisions before additions and subtractions. Okay, so what does a multiplication or division correspond with in terms of transformations? Well, multiplications by positive numbers, those are stretches or compressions, depending on the value. Multiplications by a negative, those are reflections. So actually, if I have several of those, like several multiplications and divisions, they have a stretch and a reflection. Well, then it doesn't matter which order I do those in, because like 2 times 3 is the same as 3 times 2, right? Okay, But I have to remember that additions and subtractions come after multiplications and divisions. So additions and subtractions correspond with shifts. Okay, so generally what I do is I look at the function. So if I look at this function down here, see how the thing on the farthest outside is this 2? So that's kind of out there all by itself. That's the shift up to, right? So generally speaking, I just save the shifts up and down for last, okay? Because that's the thing farthest on the outside. All right, so assuming I follow that order, I'm going to arrive at the correct final graph. With that being said, for some of these simple functions, this first one here that we're working on, this is actually a simple function. It has several pieces, but there's nothing tricky about it. So that means that, actually, if I don't follow that order for this problem, I may still arrive at the correct final graph. But we'll do one after this where actually if I don't follow the order, I'm not going to arrive at the correct final graph. So I'd say just follow this order, that way you don't run into any issues. Okay, so that means when I'm identifying step 2, I have to look for multiplications and divisions. So the multiplication that I see is by this 1/2. So my second graph is going to be incorporating that 1/2. Okay. And I should have left more room. Keep having to move that. So what does that do? So that's what we talked about above. So when I take this 1/2, it's multiplying the whole function by 1/2. So what rule do I follow? I take all the y's and multiply them by 1/2. So in that case, this is a vertical compression. Okay, so let me take each point here, multiply the y by 1/2, or in other words, divide it by 2. So my point here would be at 2, 4. My point here would be at 1/2. 0, 0. And then -1, -1/2. And -2, -4. Okay, so vertical compression. That guy's been smushed down. Okay, so now I've accounted for that was the only multiplication there. So now I go ahead and I start working on the additions and subtractions. So the next thing I'm going to do is I'm going to account for that -1 on the inside. Okay, so step 3 is graphing y equals x minus 1 cubed. Okay, so that 1 on the inside, what is that doing? That's a shift right by 1, a horizontal shift. So each point here, I'm going to take it and shift it right 1. Okay, so get rid of that for now, I think. I'm going to extend this a little bit here. Okay, so let's see. Let me take this point, shift it right 1. So now it's at 3, 4. Okay, and then the sky will be at 2.5. 0, 0 will be at 1, 0. And then let's see. -1, -1/2, be at 0, -1/2. Negative 2, negative 4 will be at negative 1, negative 4. Okay, so what else? Let's connect those points with our cubic function. Try to do a decent job graphing that. Okay, something like that. All right, and then the very last thing I have to account for is that shift up 2. So I'm going to have that same graph, but shifted up 2. Okay, so let me move this next one down. So we've got this last graph. Okay, so what is this step 4? What was it? A half x minus 1 cubed plus 2. And that's my final graph. So shifting up 2. Okay, okie dokie. So this guy will be at 3, 6. Two a half. Let's see. It's going to be at 2, 2 and a half. So 5 halves, 2, 5 halves. 1, 0 is going to be at 1, 2. 0, negative a half will be at 0, 1 and a half. 0, 3 over 2. Negative 1, negative 4, be at negative 1, negative 2. And then I have my nice, complete final graph of that function. Let me do one more thing with that final graph. Let me maybe list the domain and range. I guess that's not all that interesting. I mean, this guy extends across all real numbers horizontally and also vertically. But I'll still write it in. That's my interval notation, right? Okay, let's do another one. So this is the more interesting one. So this guy, well, the thing is with this one, I've got two things affecting the x. So let's take a look. Let me move this guy down even again. And just make sure we have plenty of room. Okie dokie. So the base graph is square root of x. Okay, so that's step 1. So that's a root function. 0, 0. 1, 1. 4, 2. Okie dokie. Then I look for multiplications. Okay, so the multiplication I see is by that -2. So my step 2, so I'm going to do this in 2 steps. Because, yes, I have a multiplication by -2, but if I really want to do this one step at a time using these transformations as building blocks, then what I'm going to do is I'm actually going to say, well, actually there I really have 2 multiplications. So I have a multiplication by a negative, and I have a multiplication by a 2. Okay, now those 2 steps I could do in the other order. Like if I wanted to do this one first and then this one, I could. Because those are both multiplications, so the order on those is interchangeable. Okay, but I'm going to go with the first option. I'm going to do the negative first. Okay, so then what is that? So remember, if x goes to -x, then what do I have? I have a reflection. And what kind of reflection? The x is becoming negative. Actually, I don't even need. So I'm going to actually be reflecting over the y-axis. Reflect. Over the y-axis. The x has become negative. So, okay, 0, 0 stays. Let's see, what about 1, 1? So the x becomes negative. So now that's at -1, 1. 4, 2 will be at -4. Something like that. Okay. You know what? I don't really like this setup. I'm just going to continue this below. Well, I could do one more step here, but we'll make more room. So the next step was the other multiplication. Okay. Again, that's inside, so it's affecting the x. Okay, now remember, x things are opposite of how they look. So that looks like in this step, I'd be multiplying the x by 2. So actually that means I would divide the x by 2. So actually this is a horizontal compression. Okay, so set up a coordinate plane again. And then let me look at my points. Okay, 0, 0's not gonna move. -1, 1. So -1, 1, I'm gonna divide the x by 2. So -1/2, 1. Okay, -4, 2. Divide the x by 2, -2, 2. And so there's that compressed root function. Okay, and then there was one more step. This is the tricky step. So the last step here, I have to account for this 4 underneath the root. So you have to be careful because that 4 is also affecting the x. So here's the thing. So let me set up step 4. Now I'm graphing the final function. But in. But you see how we already accounted for the fact that we have this -2 in front of x? So actually what we have to do is we have to say, well, we already accounted for that -2. That means we have to factor that -2 out of that expression, because both of those quantities, both the -2 and the shift, those are both affecting x. So we've already accounted for that factor of -2 in front. So I have to factor that out. Otherwise, I can't see the correct shift, which is actually a shift left by 2. Okay, so what I do in this step, I take all the x's, I'm shifting them left 2. Okay, so I'm subtracting 2 from each of the x's. So 0, 0. Now is that -2, 0. -1/2, 1. Subtract 2. So -2.5, 1. Or -5/2, 1. -2, 2. That'll be at -4, 2. And there we have it. So now if you want to double check, you can always plug in a point. So what if I pick this point? If I plug -4 in the function, just make sure we get the correct result. Oh, look at that. Indeed, we've got the correct graph. So I'll let you check the other 2 points if you want to. So this is one where if we did not follow the order, we actually would not arrive at the correct graph. I don't know, let me just try to illustrate. So what if student was like, okay, let me take this, I'll graph square root of x, then I'll go ahead and do my shift left. Then it'd be here. Then I'll do my reflection. Oh, well then the graph would land here. That's not going to be the correct graph, right? So with something like this, if you don't follow the order, you're not going to arrive at the correct final graph. So that's important. Okay, so I don't know, those are the basics of this section. Let me maybe come up with one more example here. Let me say, write the equation of the, I don't know, I'll say the, let's say of the function with base graph y equals 1/x, say vertically stretched by 5, shifted right 10, and down 2. Okay, so this is saying, starting with the base graph y equals 1/x. So that one, by the way, if you remember that guy, that's called the reciprocal function. So that graph, this is the one with the asymptotes. It looks like that. Okay, but anyway, my goal is just to write the equation of the function. So let's see. I guess step 1, I would start with the base graph, 1/x. Then I would, okay, do my vertical stretch by 5. So what does that mean? That means I take the whole function and multiply it by 5, right? So I multiply straight across, 5/x. Okay, what's next? Shift right 10. So that 10 needs to go with the x, right? So it would look like this. That would give me that shift right 10. And then down 2. So that means I take the whole function, shift down 2. Okay, then maybe should I write in my last step, should I use some functional notation? So there's my function. Pretty easy.